Good day, viewers. You are welcome back to Tindanious Maths and Science Tutorials. If you are new here, kindly share, like, subscribe, and comment for more interesting and updates. Try and click on the subscription or the bell button to subscribe. Today, we are going to talk about something very important so far as calculus is concerned, specifically under limits of function. Now, when you have lim as theta approaches 0 of sine theta this way, the result is 1. So we have lim as theta approaches 0 of sine theta over theta equals 1. Also, limit of the function as theta approaches 0 of 1 minus cos theta then over theta is equal to 0. What does it mean? Do you get it that way? So we are going to prove. So let's look at the proof of that. So viewers, let us consider a unit circle. So what do I mean by a unit circle? When you have a circle, okay, with radius of 1, that is what a unit circle. So we want to choose r equals 1 to make our life, simple. Do you get it that way? Yes. So when you draw a circle and when you draw a line from the center to touch any point on the circumference, it's called what? A radius. So this is radius with the magnitude of what? Of 1. Now, let me draw a tangent, okay? So a line that is drawn to touch a curve, okay, or a circle at one point only. That is what? A tangent. If you are new here, kindly visit my previous lectures on calculus, okay? That's differentiation pertaining to tangent, normal, and gradient, all right? Tangent is different from secant or secant line. So if I draw a line to pass through this circle, okay, this way, to pass through at, let's say, at 2 points, okay, 2 given points this way, that is what is known as what? A secant line. But once I draw a line, okay, to pass through, it will not pass through, but when I draw a straight line to touch the circle at 1 point, that is what we call what? A tangent. But for a secant line, 2 points. I hope you are getting it that way. But our business for today isn't what? A secant line, but the tangent. So now, let me extend this to this side. The condition still holds because from the center to any point on the circumference, a tangent is still what? With magnitude of 1. Now, there's an angle theta here, all right? So let me label my diagram. So I have A here, I have, let's say C, all right? C, okay, this way. So now, viewers, or let me do it clearly. Okay, so this is my point C. So viewers, now, this is 90 degrees, right? Right, good. So I'll use a basic trigonometry identities, the SOHCAHTOA, okay? Because I know this side. I know AC to be 1. I know AB to be 1, okay? But I don't know what CB or BC, okay? So this is what we are going to do. Remember, this is a straight line, okay? That is what? The tangent. Now, because I'm looking for this, I'll use the tan identity. So if I use tan of the angle theta is equal to tan, you know that tan is what? Opposite over adjacent. And what is my opposite? The opposite is what? Is this, right? So I have it to what? CB. Then all over tan is opposite over adjacent. And adjacent is what? Is A what? AB, right? But we know that, our AB, look, AB is the same as what? It's the same as R, which is equal to what? 1. So therefore, we can say that tan theta is equal to CB, right? So I have CB, then all over AB, but AB is the same as R, which is equal to what? 1, right? So therefore, CB is the same as what? It's the same as tan then of the angle theta. As simple as that. So viewers, in view of that, I'll put what? Theta here, tan theta here, representing that CB or BC. So now, viewers, we know that ACB or ABC forms what? A triangle. Is that not so? So we are going to work out for the triangle, okay, the area of the triangle. So I would say that area of triangle ABC is given by the area of triangle ABC from our basic calculus is given by what? Half base times what? Times our height, which is equal to, so I have 1 over 2, then times what is the base? Considering this triangle, okay, the base is what? Is AB, right? AB or R. So AB, then times H. What is the H? So viewers, the H here is this, is the line. So it's more or less I will have it to be this way. You get it that way. So this is the tangent we are talking about. The C what? B. All right. So that is our H, which is what? CB, which is equal to, we have half, then times, do I know AB? So AB is what? Is R. So times R, then times, do I know CB? CB is what? Is tan theta, right? So tan of the angle theta, which is equal to half times, what is R? R equals what? Equals 1. So times 1, then times tan theta. So therefore, the area of triangle ABC is what? Tan theta times 1 is what? Tan theta divided by 2. So tan theta over 2. That is the area of this triangle. As simple as that. Now, viewers, when you look at the guy carefully, realize that this is a sector. Look, you see. So this is the tangent, and from here to here, this side, that's the sector, something like this, with respect to this angle. So you have R and what? And R. So we also look for the area of the sector. So area of our sector is given by, again, from basic algebra or from our pre-calculus. It's given by half, then times R. Here the base here is R. So times R, then times the angle, which is what? Which is our theta. So the area is R times theta. It's R theta, right? But remember, R is equal to what? It's equal to 1. So I have half, then times 1, then times what? Times theta. So therefore, the area of the sector is given by theta divided by 2. So this is the area of what? The sector. So viewers, for want of space, let me come here. the same diagram. We said we have a circle with radius r this way, and this is our tangent, right? This is our tangent. So this is theta, r equals 1. This is r is equal to 1. This is our center. And we said this side is B, A, and what? This side is C, A, and B, right? So this place, this side, that is what? Our sector, right? And this is our tangent, okay? So viewers, now we are going to draw a line, okay? We are going to assume that there is what? There is a line joining this side to this side. Do you get it that way? So a line joining this side to this side. So viewers, let's come here. See this side, we have, this is the area of what? Of the sector. And this side, you see, we have the tangent this way, right? So we found for this, and we found for the entire area of the triangle. So we found for two things. But we are left with the last one because we said, let's draw what a straight line from this side to touch this side. Okay, so that means we are also going to find for the area over here. We are interested in this area, this shaded portion. So we add the shaded portion to this, okay, it forms what the entire triangle. Okay, so viewers, so this is what we are looking for, this side, okay, yes, this side. So let me call this side D. Okay, so viewers here, again, the same diagram. Let me call this side D. All right. So we now have what? A, B, D. A, B, D. So we are going to calculate for that area. All right. So viewers, from pre-calculus, we already know that when you have a triangle this way, we have, let's say, a triangle at all. Then you have R, then you have an angle this way. Viewers, now the area is given by, the area is half, then times R, then times R, then times sine of the angle theta. So we'll be having half R squared sine theta. So viewers, so having done that, we have what here? R over here. We also have what? R over here. And we have what? The line we drew. Okay, we drew this line over here. We constructed our own line. And it's forming something like this. Do you get it, David? So something of this nature. And from our basic pre-calculus, you know the formula, right? So if you have here to be A, here to be, let's say, B, okay? You have half A times B times sine theta. If here is also A, you have half times A times sine theta. That is how it goes. So we are going to employ the same analogy over here. So therefore, I can say that area of A, of triangle A, then what? B, then what? Then the D, and the D over here is given by, so viewers, note, we have this portion and we have what? This portion. See, in our first, or from the introduction, remember we said we found for the area that's A, B, and C. Look at that with the entire diagram, okay? Including what? The tangent. Do you get that? But here, we are interested in finding what? The area of A, B, and what? And the D. Okay, C is not included. So that is the difference between this and viewers and the first one, which is this. All right, so this is A, B, C. A, B, and C. Okay, including what? The tangent. So this is what? That you have a tangential surface. You get it that way, but here we are interested in, remember we drew a straight line over here. So we are now interested in triangle A, B, and D. Do you understand? All right. So we know that we have half times our R times what? Our R, then times sine of the angle theta. So therefore we have R times R gives what? R what squared, we have sine theta over what? Over 2. So what is R? Remember, R equals 1 from here. 1 times 1 is 1 squared. Then times what? Sine theta divided by 2. So our final answer is sine theta over 2. As simple as that. And this becomes what? The area of triangle ABD. So viewers, having done this, we are now going to focus on this. And we're now going to focus on that. And lastly, on this. So we can say that area of triangle ABD is less than or equal to the area of sector. So have area of sector which is less than or equal to area of, so the area of triangle A, B, and C. So what do we have? Do I know the area of triangle ABD? Yes. So I have it to be what? That's sine theta over what? Over 2. I have less than or equal to. Do I know the area of sector? Yes, over here. Area of sector is what? Theta over 2. So I have it to be what? Theta divided by 2. Then less than or equal to the last one, area of triangle ABC. And what is the answer? We have area of triangle ABC giving us what? Tan theta over 2. So tan of the angle theta over 2. Viewers, what is common? 2, right? 2 is common, right? So we cancel out. So this becomes what? Sine theta less than or equal to theta less than or equal to our tan theta. As simple as that. So viewers, what do we do now? Now we can divide through by sine theta. So dividing through by sine theta, we have this. So we have sine theta over sine theta less than or equal to theta over sine theta less than or equal to then tan theta then divided by sine theta. Remember that tan theta is expressed as what? Can be expressed mathematically as what? Sine theta over what? Over cos theta. This is from our pre-calculus, okay? Basic trigonometry, right? So therefore, we can say that this theta cancels this, sine theta cancels sine theta. So we have 1 less than or equal to theta over sine theta less than or equal to, what do we know for tan theta? Sine theta over cos theta, right? So we have sine theta over cos theta for the tan divided by what? Sine theta. So sine theta cancels sine theta. So we have 1 less than or equal to theta over sine theta less than or equal to, sine cancels sine 1 time. So we have 1 over cos theta. So viewers, we had this, right? So what can we do from here? So viewers, we can do this. We can flip whatever we have over here. Okay, why are we doing so? Remember, we are proving lim as theta approaches 0 of what? Of sine theta over theta, which is equal to 1. So viewers, have you seen the concept? Have you seen the analogy? So we are going to employ the same strategy over here. So I'll say 1, because we are flipping, we will also reverse the inequality sign. Remember, when you are multiplying or dividing 2 by negative, the inequality sign reverses. The same also applies over here. So once you flip, you reverse. So here tends to what? Greater than or equal to what? Then I have sine theta over theta in order to suit this. So I have, you also flip this. So I have greater than or equal to what? Cos theta over 1, which is the same as cos theta. So viewers, we can still, we can rearrange this. So by rearrangement, we can say that cos theta, right? So because I'm rearranging it, okay, this way. So in other words, I want to what? I want to flip it this way, right? So I'll also do justice to the inequality sign. So have cos theta less than or equal to what? Sine theta over theta. Then I'll also reverse this, which is less than or equal to 1. The whole idea is this. Viewers, if I have x greater than or equal to 2, then I can also say that this 2, okay, is less than or equal to x. Do you get it that way? As simple as that. So once I turn it this way, I have to also reverse the sign. That's why I said by rearrangement. It's just the same. All right. So viewers, now what can we do from here? Think about it for 3 seconds. What can we do from here, viewers? We can't do anything from here, right? So we are now going to apply limits. Okay, we are going to apply limits over here. So applying the limit would say that lim as theta approaches 0 of this, of course, theta less than or equal to, then limit as theta approaches 0 of sine theta over theta less than or equal to, then limit as theta approaches 0 of 1. So what can we do over here? Viewers, this is very, very trivial. So here, we are going to apply limits by direct substitution. What do I mean by direct substitution? You simply substitute theta approaches 0 or theta equals 0 into this. Then, into all of them, right? So this is what we are going to do. So we have cos theta here. What is cos theta? So that what is cos 0? Wherever you see theta, you put 0 there. So cos 0 is simply 1. Then less than or equal to. Viewers, you are not going to evaluate this. Why? Why? Because this is the question. Because we are finding for lim as theta approaches 0 of sine theta over theta. This is what we are looking for. So we are going to maintain this as limit as theta approaches 0. Then I have sine theta over what? Over my theta. Then less than or equal to. Limit of a constant is always a constant. Okay, so lim 1 as theta approaches 0 is still 1. Do you get it that way? So now we have two functions being equal this way. Okay, we have a middle function. So let's say if you have j of x and you have f of x and you have g of h. Once the one at the far end, okay, if they are the same, then the limit, okay, or we say L, or the value, okay, is equal to lim of the function, okay? That's the middle one. So viewers, I'll shoot a video on this to throw more light on what I've just said. So this brings us to what we call the squeeze theorem. So the what? We have the squeeze theorem or the sandwich theorem, which states that once you have the limit of this function, okay, when you evaluate, you see the value here, which is also equal to this, then the answer is equal to the middle function. Okay, so I'll do videos on that proper. Okay, so we can say that using the speech theory, then you can say that limit as theta approaches 0 of then sine theta over theta is equal to what? Is equal to 1. Viewers, have you seen how simple the proving is done? Very, very trivial. So we will now build on this to arrive at the second one. But remember, we're also looking for lim as theta approaches 0 of 1 minus cos theta over theta, giving us 0. Okay, so we are just going to build on this. So viewers, doing that, okay, so we have this. So you already know that lim as theta approaches 0 of sine theta over theta equals 1. Let's square everything. So when we square everything, we'll be having lim as theta approaches 0. When I square this, I have sine squared theta, okay, then over what? Over theta squared. Whatever you do to the left hand side, you do same to the right hand side. You also what? You also square this, right? So therefore, we can say that lim as theta approaches 0 of sine squared theta over theta squared is equal to 1. But remember, from Pythagorean identities, we already know that sine of the angle theta, okay, so sine squared theta added to cos squared theta is always equal to 1. Do you remember this from trigonometry? So what is our interest? We are interested in what? Sine squared theta, right? So I can say that sine squared theta is equal to what? 1 minus cos squared theta. Okay, you can use the idea of double angles, okay, but let us use this since this is very simple. Okay, the double angles too can also be simple for others, all right? So let's just pick one identity and build upon it. So we are just recalling our Pythagorean identities from our basic pre-calculus. So having done this, then I can say that this sine squared theta is equal to, viewers, this is difference of two squares. Why? Difference of two squares because you have one squared. Difference of two squares. As a result of that, I can say that you adding the terms in one bracket, then subtracting them in another bracket this way. This is what we call what the difference of two squares, right? So this is the same as that, and this is the same as that. So we are now going to substitute this into this. So I can say that lim as theta approaches 0 of sine squared theta over my theta squared is the same as this. This is the same as 1 plus cos theta. Then times what? 1 minus cos theta this way. Then all this is over theta, this is over theta. Okay, so theta times theta gives theta squared. Then this is also this and that. So viewers, we had this right. So we said when you evaluate this, you should get 1. Is that not so? This from here, this side equals 1, right? So sine squared theta over theta squared is equal to 1. Okay, but this is the same as this, which is equal to 1. So we can therefore say that limit of theta, okay, so limit as theta approaches 0 of this, which is the same as that, 1 plus cos theta over theta multiplying 1 minus cos theta over theta be equal to 1, viewers, we can spread the limits. All right. So this is the same as, viewers, if you want to know the properties regarding limits, in other words, the rules of limits of functions, go and watch my previous lecture videos on introduction to limits. Okay, whenever you have things of this nature, this limit will affect this and will also affect that. Do you get it that way? So this is the same as lim as theta approaches 0 of this 1 plus cos theta over theta, then multiplying, then you apply the limit on this, times lim as theta approaches 0, then of 1 minus cos theta over theta equals 1. Viewers, you ask yourself, what are we looking for? What are we looking for? So remember, we are what? We are looking for this. We are looking for this. Is that not so? This is what we are looking for. 1 minus cos theta over theta. So viewer here, they say, are we interested in this? Not at all. We are interested in what? The negative one. So we are now going to what? We are now going to throw more light on this. So since you are looking for this, we will make this the subject. Is that not so? So making this a subject, we have lim as theta approaches 0 of 1 minus cos theta over theta being equal to 1 over this, right? So I have 1, then divided by lim as theta approaches 0 of 1 plus cos theta then over theta. As simple as that. Now, what do we do here? We can, viewers, we can flip this. We can flip this. So now, we know that the reciprocal of the limit is the limit of the reciprocal. Let me take it again. The reciprocal of a limit is the limit of the reciprocal. As theta approaches 0, then of 1 minus cos theta over theta is equal to, then you reciprocate. So this becomes lim as theta approaches 0, then you have theta, then over 1 plus cos theta. As simple as that, viewers. So viewers, we are now going to evaluate this using our direct substitution. Okay, so wherever you see theta, you put 0 over there. So using the direct substitution, you have what? Wherever you see theta, put 0. So you have 0, then all over, then 1 plus cos 0 is 1. So I have this to be 0 over 2, which is equal to 0. As simple as that. So hence, hence the limit as theta approaches 0 of 1 minus cos theta over theta is equal to 0. So this is valid, right? Very, very true. So viewers, note these identities very well, especially when you are tackling limits of trigonometry functions. Viewers, this is the end of the tutorials. If you have any concern, any idea, if you have more information on this, I will appreciate everything in the comment section. Remember, sharing is caring, right? If you find this video very, very exciting and more impactful, leave your comments for me. Do well to subscribe, share, like, and comment for more interesting video and updates. Bye.